Today we're going to focus on the neural diseases. So today we're going to talk about the Alzheimer's disease, AD, and the mouse models from these two famous A-beta pathology and the Tau pathology. I guess previously a lot of people were focusing on the A-beta pathology, yes, right? Getting rid of the plaques. But looks like it's not the root cause of the disease. And people are shifting focus to Tau, which we're going to talk about today.
Before talking about the HUGO-Tau as a new word, the HUGO, yes, I would like to talk a little bit about the entire background of the HUGO project at Cyagen.
Yes.
The HUGO is short for Humanized Genomic Ortholog.
Yes.
That actually means replacing the entire gene in the mouse.
The genomic sequence.
Genomic sequence in the mouse.
Not just the CDS. Yes.
By human. By human genomic sequence. And Tau, what we just talked about, the humanized Tau model, is made by this technology. To make this HUGO strain, or the significance of HUGO strain, is we replace mouse genomic sequence by human, as I just described. And the purpose of doing that is to make the mouse model human relevant.
And so in your hand, what do you see? I mean, we have the wild type humanization of the, yes, Tau, human Tau, right? And we have the, on top of the wild type humanization, we have the put in the mutation, the P310 mutation.
Yes.
Right. So what have you been seeing so far?
I have to first talk about why we need humanized Tau. It's because in the root, the human Tau and the mouse Tau, they are different. In adult mouse, there is only 4R. That means we have only half of the Tau.
That's one of the reasons that we need the
yes,
HUGO.
That's one of the reasons why at the very beginning I insisted that for studying Tau-related disease, we have to put human Tau inside mouse. Otherwise, we lose half of the diseases. We lose half of pathologies.
So what do you see in these models?
We set 3 time points. At 3 months old, at 6 months old, and at 9 months old. At 3 months of old, it's safely for us to say there is no behavioral pathology. The next time point is 6 months old. Now things are getting interesting. We didn't see too much of the motor dysfunction in those lines, neither compared to their own HUGO wild type or the black 6. But we did see some deficit in cognitive function, especially in the P301S mutation line. We didn't see anything in the P301L line at 6 months old. And this is exactly happened in human patients.
Okay.
The human patients of FTD, the human patients with AD who bears the P301S mutation,
has an early onset.
Yes, has early onset and accelerated pathophysiology.
Okay.
That means at least in terms of the novel object recognition test, in terms of this episodic memory test, our HUGO mouse behave exactly like human. By the end of our experiments, 9 months old time point, we still didn't see any motor dysfunction in all those lines, but we did see the cognitive deficit in both P301L and P301S. Now it's catching up. P301L is catching up. Eventually, the cognitive deficit happened as expected, yet slower than P301S. Also exactly like in human.
What about the wild type Tau?
The wild type stay functional, clever, capable of recognizing the new things.
Not too much
which
different
is very important actually, because despite all our hope, we expect the H-Tau functions in mouse as in human. They still human sequence.
Yes.
So there is a slight possibility that this wild-type human tau doesn't work in mouse.
Sometimes.
Now, sometimes. It's unfortunate, it's unwanted, it happens.
But not this time.
Not this time.
Luckily.
By comparing the HUGO-Tau wild type to black 6 mouse, we didn't see any alterations. Not in cognition, not in general behavior, not in motor function.
Wow.
This time, it worked. By completing the animal behavior test, we conducted pathological tests using the brain tissue from all those 4 strains. While you know, in human patients, the most important pathological hallmark by staining is what we call neurofibrillary tangle, which is a tau aggregation inside the neurons.
Yes.
So this time, we expect to see the same thing in those mouse models. This is the staining result. And as expected, using the HT7 antibody, we detected nothing in the black 6 mouse. And also as expected, we detected a bunch of tau in the H-tau wild type. That means the human tau is expressed as expected.
Yes.
And interestingly, we detected also HT7 signal in the P31L and P31S mutant lines. And after the HT7 detection, of course, we ought to detect the pathological tau. We ought to use the 88 to detect it. And as expected, we didn't see much in the black 6.
As expected.
As expected. And this time, we didn't see much also in the human tau wild type. As expected, there is no pathology. They behave normally, just like the black 6.
Yeah.
And we detected a bunch of signal in the P31L and the P31S. Since 88 is specially detecting the phosphorylated tau, we could safely say that there are a severe hyperphosphorylation process of tau happening in the brains, especially in the hippocampus of those mouse.
Which is characteristic of the AD.
Of the AD, of the FTD, of any tau-related pathology.
Okay.
So a trend in today's medical society is we use biomarkers from peripheral blood. And one of the most accurate biomarkers related to behavior, related to all the scoring system for diagnosing AD is tau.
Wow, good to know. Now we're providing the best tau model to the industry.
Yes, and actually you can imagine with these tau models, now more and more this kind of peripheral blood test kit can be explored, can be formed, can be investigated, can be invented using our mouse models.
So it's not just therapeutics, but also
diagnosis.
Yes. So this time we have this model, the full human tau sequence is working happily in mice, and it's showing us a good tau pathology, recapitulate the human disease, not just AD, but all tau-related
disease. That means if we would like to develop a tau targeting treatment using animal models, we better be sure that the tau is recapitulated accurately in these animal models.
Yes, yes.
Which is ours.
Oh, wow. Great.
Cyagen help you discover life.